In this video, we're going to be taking a look at the increasing and decreasing test, which is essentially a three-step process that's going to help us identify the intervals on which a function is increasing versus the intervals on which it is decreasing. Okay? So, the increasing and decreasing test. The first step is to compute the derivative f prime. Okay, so that's our step one. Step two, we want to find all numbers for which f prime of x equals 0 or f prime of x does not exist. And if this sounds really similar to the idea of critical numbers, that's because it's the same thing. Okay, so what we talked about in the last video on critical numbers, step two here is finding the critical numbers. Then in step three, we are going to solve some inequalities. Specifically, we're going to solve the inequalities f prime of x is greater than 0 and f prime, changed pages there, sorry, f prime of x is less than 0. And you can do that either graphically or algebraically. And then these solutions that we get tell us where the function is increasing and where it's decreasing. If f prime of x is greater than 0, that's when we know our function is increasing. And if f prime of x is less than 0, that's how we know our function is decreasing. Okay, so we're going to take a look at a couple of examples of how to do this. I'll show you the method that I use. There are other methods, and most of them are discussed in your book, but I think this method is pretty straightforward. So let's say that we wanted to find out where our function is increasing and where it's decreasing, like what intervals we're looking at. And the function I'm going to be looking at is, we're going to look at, we have, let's see, f of x equals 4x cubed minus 9x squared minus 12x plus 7. And we want to find the intervals on which the function is increasing and decreasing. Okay, so the first step, if we're thinking about that three-step process, the increasing and decreasing test, the first step is to find the derivative, right? So I'm going to go to my function and I want to find f prime of x. So the derivative of that first term, 4x cubed, that's going to be a 12x squared. Derivative of the second term, negative 9x squared, that's going to be a negative 18x. The third term, the negative 12x, that's going to be negative 12. And the derivative of positive 7 is going to be 0. Okay, so there's our first step. Find the derivative f prime. We did that. Second step, we want to find the numbers where that derivative is either equal to 0 or where the derivative does not exist. Again, being a polynomial function here, this one doesn't have any values where the derivative doesn't exist. I mean, if your derivative, as an aside, if your derivative was something like 1 over x minus 3, as an example, then x equals 3 would end up being one of your critical numbers, because if we plug that in here, we get 1 over 0, which is undefined, and therefore the derivative does not exist at that point. Okay, but we don't have anything like that going on here. So we are just going to be looking for our critical numbers where this function, this derivative, is equal to 0. So we're going to set it equal to 0. And let's see. If we divide, all of these have a common factor of 6. So I'm actually going to divide out by that. Again, just because that sometimes makes the factors easier to see. So then we get 2x squared minus 3x minus 2. And then again, here we can either factor or use the quadratic formula. To factor this, you can use whatever method you're most comfortable with. I tend to just use the trial and error method because that's how I learned. But you certainly don't have to do it that way. Let's see. I think we're looking at this. Let me just double check that. So firsts would give me 2x squared. Outers is going to be negative 4x. Inners is plus 1x, so that gives me negative 3x. And the last is negative 2. Yes. Okay, so those are our factors. And then we can set each of the factors independently equal to 0. So either 2x, my pen doesn't seem to want to work. Let's see, 2x plus, there we go, 1 equals 0. That's one option. Or x minus 2 equals 0. And then solving each of these for x, this first one, 2x plus 1 is equal to 0. That gives us x is equal to negative 1/2 as a critical number. And the second one, x minus 2 is equal to 0. That gives us 2 as a critical number. Okay, so that is that second step. Find all numbers for which f prime of x equals 0 or f prime of x does not exist. So these are the ones that we need to worry about. Now, in the third step, we then need to find the places where the derivative is greater than 0, where it's positive. Those are going to be our increasing intervals. And we need to find where it's less than 0, where it's negative, because that's going to give us our decreasing intervals. And here is how I like to do this. For step 3, I make a number line. And on this number line, I'm going to put those critical values. So we had negative 1/2 and we had positive 2. Now, why am I doing this? So when I think about my possible x values go from negative infinity to infinity. I already know the values where the derivative is equal to 0. Those are my critical points. And those points for this particular function divide that real number line, that x number line, into 3 possible intervals. There's the interval to the left of negative 1/2. There's the interval between negative 1/2 and 2. And there's the interval that's greater than 2. And so if I pick a test point to plug in to the derivative from each interval, that will tell me the sign of the sign of the derivative for all the points in that interval. Okay, so here I want to pick some test points. To the left of -1/2, I'm just going to pick -1 as my test point because it's easy. You don't want to pick numbers for your test point that are not going to be easy to work with. Between -1/2 and 2, I'll pick 0. And then to the right of +2, I'll just pick 3. And those are my test points. And what I'm going to do is I'm going to plug each of those test points into my derivative, and all I care about is what the sign of the derivative is, right? The increasing and decreasing test just talks about the sign, doesn't talk about the value at all. So the numeric part, we don't care. We just want to know what's the sign. Okay. So going back here, our derivative was 12x squared minus 18x minus 12. Okay, so that is our derivative. And I want to find f prime of each of those 3 test points that I've picked. So I want f prime of -1. I want f prime of 0. And I want f prime of 3. So here I'm going to have 12 times -1 squared minus 18 times -1 minus 12. 12 times -1 squared, that part's just going to be 12. Then I have minus 18 minus 12. And that is going to be negative, right? Because the 12 minus the 12, those cancel. -18 is the value of the derivative when x is equal to -1. So that test point, when I put it in, it gives me a negative sign for my derivative. That means that this entire interval to the left of -1/2, the sign of the derivative in that entire interval is negative. Okay. Then we're going to look at f prime of 0. So we'll have 12 times 0 squared minus 18 times 0 minus 12. Okay. So, oops, I just recognized. I'm so sorry. I have a mistake here. That actually should have been a positive 18, shouldn't it? Because that was negative times negative. Okay, so backing that up. That actually should be positive right there. Okay, I apologize about that. The process is still the same. I just somehow missed the fact that that was negative 18 times -1. So it should be plus 18. Okay, so in this one, when we're putting in the 0, 12 times 0 squared is 0, minus 18 times 0, still 0, minus 12. So that's a -12, which means here we have a negative sign for our derivative in that interval. Okay. And then for our last one, putting in the value of 3, 12 times 3 squared minus 18 times 3 minus 12. Well, 3 squared is going to be 9. 12 times 9 is 108 minus 18 times 3 is 54 minus 12. When I crunch all of that through, 108 minus 54 minus 12 leaves us with 42. And that is positive. So in that interval to the right of the critical number of 2, our derivative is going to be positive. So in terms of where is the function increasing and decreasing, it's increasing in the intervals where the sign of the derivative is positive, and it's decreasing in the interval where the sign of the derivative is negative. Okay, so that's all the work to find those intervals, but then how do we report our final answer? What does this look like? So if I go over here, I'm going to get a new screen, and I can say the function is increasing on, well, it's increasing when I look at this first interval. That's everywhere all the way to the left, which is negative infinity, up to, but not including the value of negative 1/2, right? Negative infinity up to, but not including, so it gets that round parenthesis, negative 1/2. We can't include the negative 1/2 because the derivative isn't negative there, it's 0. Okay? And then we can say, and we have another interval where it's increasing, right? 2 all the way to the right. So that's going to be 2, again, not including the 2, and infinity. Your critical values are never included here. Okay, so these are always going to be open parentheses. Also, you can't use your critical values as a test point because the whole deal is that the derivative is neither positive nor negative there, it's 0. Okay. And then in terms of where the function is decreasing, it's decreasing on the interval between negative 1/2 and positive 2. And again, we're not going to include either of those endpoints. Okay, so that is how we would put our final answer into writing. One last important thing to pay attention to here. You'll notice that in this problem, we had our derivatives, the signs went negative, or sorry, positive, negative, positive. And periodically I have people say, oh, well, then don't you only have to test one and then you just know that they alternate? That actually doesn't work. There are times when you might have 2 consecutive intervals where the sign of the derivative is the same. So you got to make sure to test a point in each interval.